The corner cabinet spaces in kitchens tend to be underutilized due to their awkward positioning. Their location makes it difficult to access food items that are stored deep inside the corner. Forgotten items can be left to expire, wasting the user's food and money. For people with limited mobility, maneuvering this hard-to-reach space can lead to physical strain or injury. This risk is especially great for Canada's aging population. As of 2017, 16.9% of the Canadian population was aged 65 or older, and this number is expected to increase to 25% by 2047. Current solutions include using a rotating Lazy Susan or building a wide diagonal cabinet door that extends into adjacent corner space. Diagonal cabinets decrease the size of more easily accessible adjacent cabinets, and Lazy Susans require users to turn heavy shelves in addition to also wasting adjacent cabinet space. A general solution must retain the standard base cabinet size of the corner, leaving adjacent cabinet space untouched, and does not require users to exert physical strain by reaching deep into the cabinet. It must allow users to identify their food items by viewing the label, similar to a traditional cabinet experience. The Handy Pantry is an autonomous food storage device to be placed into the vacant corner cabinet. It occupies just the corner space of a standardized corner cabinet and involves an autonomous loading and retrieval mechanism which minimizes a user's physical interaction with the inaccessible corner region. It contains a loading and retrieval dock installed on top of the counter. These qualities distinguish it from current solutions of diagonal cabinets or Lazy Susans, which either intrude on adjacent cabinet space or require physical exertion by the user. With the use of mathematical modeling, we were able to make many design decisions for the Handy Pantry. For the rotational mechanism, the motor torque was calculated by considering the moment of inertia of the platform, angular acceleration needed to achieve optimal rotational speeds, and the friction of the bearings used. A gear train assembly was implemented so the torque requirements were able to be even lower at the cost of higher angular velocity. This also allows for a compact design and less weight on the motor. To aid in rotational positioning, Hall effect sensors were implemented. Finite element analyses were used to determine optimal magnet position and orientation. Magnets were stuck to the base plate with a sensor just mounted off the rotating plate. The rotational motion triggers the sensors as the magnets pass by, hence the position can be determined. To determine the best motor for horizontal extension of the arm, the target acceleration and expected friction between the heaviest food items and platform surface, as well as between the rack and aluminium fixture, were calculated. Based on the pinion gear diameter, we calculated the required RPM in order to achieve our target speed. For vertical transport, we first determined the required linear speed for an 8-second transport. This allowed us to find accessible ranges for the motor's RPM and lead screw lead. The lead screw torque equation was used to determine the necessary torque for both starting and running the motor with this lead. To aid in vertical positioning, an ultrasonic rangefinder was implemented which uses sound to measure the platform position with 1 centimeter accuracy. The motor controls were compactified so all three can be controlled by one Arduino. The Handy Pantry has an easy-to-use interface which requires little navigation through the text-based UI, as well as accessibility features such as a preset template option for frequently used items and an option to put back a recently removed item. Currently, the Handy Pantry is able to move to its desired location as well as input and retrieve an item. This is made possible by the connection between the text-based UI and the Arduinos controlling the motor movements. The motors are able to synchronize and approach each location with the correct input or retrieval sequence of motions. The speed of the Handy Pantry allows a user to completely input and retrieve an object in 4 and 5 minutes respectively. This includes from interacting with the UI to inputting or receiving the item. All this is able to be performed with a power efficiency of 100 watt-hours per one item retrieval, insertion, or just sitting idle for 24 hours.